Hello, sixth grade, and welcome to ELA's Unit 1, Week 3. Let's go ahead and start with our vocabulary. Your first word is the word submerged. When something is underwater, it is submerged. The submerged diver saw many fish. What vehicles might become submerged? Our second word is the word compartment. A compartment is a separate section for something. My mother's purse has several compartments, so think of it as organized spaces for things. You may have different compartments on your backpack where you have different zipper pockets and things for different items. Your third word is the word engulfs. A whale engulfs or swallows up its food whole. So to engulf means to swallow up or to wrap around or cover. The coral garden fades to black as the darkness engulfs it. Next, we have the word maneuvering. Maneuvering means changing position. After some careful maneuvering, the submarine floated to safety. You can think about when your parents are driving a car and they're trying to get it into maybe a parking spot that's kind of small. They are maneuvering the car to make it fit. Your next word is the word flanked. Flanked means to be placed or positioned on either side of something or someone. So kind of like surrounding it from both sides. The queen was flanked by bodyguards as she strolled down the aisle. So that means she had bodyguards on both sides of her. Next, you have the word obscure. Obscure means to hide something from view. Mounds of mussels completely obscure the bottom of the ocean. What might obscure your view of the sky? So remember, obscure is just a fancy way of saying that something is blocking your view. Next, we have the word classification. Classification is sorting things into groups. You classify them or you put them in groups of things that are similar. Based on the classification of the clothes, it was easy for Kendra to find her blue sweater. So you might classify things in your closet by putting the sweaters together and the t-shirts together and the jeans together and the pajamas together. You're sorting them into groups based on some kind of similar something they have about them. Species are groups of related living things with very similar characteristics. So different species of cats all have very similar characteristics. They have paws, they have whiskers, they have ears that point straight up, they're covered in fur. So species are groups of related living things that have very similar characteristics, like different species of birds. They all have very similar features like claws on their feet, they all have beaks, they all have wings, and so on. Now, for your spelling this week, we're going to focus on frequently misspelled words. So these are words that a lot of people make mistakes on. You have the word accuse, affect, beautiful, bought, busy, caught, different, done, effect, embarrass, especially, accept, excuse, library, minute, nickel, probably, there, trait, remote, bathe, recommend, and separate. Now, frequently misspelled words usually fall into a couple different categories. Some of them are words that are misspelled because they have double consonants and people forget to put the doubles. Sometimes they're misspelled because they have similar sounding, people will put down a similar sounding word by mistake. So they'll use a homophone, a word that sounds the same, but it actually means something different. Or they're words that have kind of unique spelling patterns that are not common. So double consonant words could be like the word embarrass. It has 2 R's and 2 S's in it. Different has 2 F's. Mississippi has 2 sets of double S's and 1 set of double P's. Affect and effect both have double F's in them, and accuse has a double C. Now, similar sounding words, we call these homophones. They're words that sound the same, but they're spelled differently and they have different meanings. Like the word there, and there. THERE is talking about a location like here and there. THEIR talks about something that belongs to someone. It is a possessive. So this is their car. Or THEY apostrophe RE is a contraction. That's what you get when you put they and are together, like they are going to the park. You have two, and two. TOO means also or a lot. TO is a direction, like we're going to the park or please go to your room. And TWO is the number two. You have toe and toe. TOW means to pull something. TOE means a toe like on your foot. You have flu and flu. FLU like the illness, or FLEW like the past tense of fly is flew. You have blue, the color, and blue like the past tense of blow, like she blew bubbles during her recess. Or you have weather and weather. WEATHER means the weather outside. Like, is it sunny? Is it rainy? Is it hot? Is it cold? Weather, WHETHER, is choosing between things. I'm not sure whether or not we're going to go to the park today. Unique spelling words or unique phonics patterns. Phonics patterns are when you're relating specific sounds to certain letters. Beautiful has a lot of vowels in it that you're not pronouncing. So you're not pronouncing all of the vowels in it. Excuse has a Z sound in it, not an S. Busy, very similar. Nickel, NICKEL versus NICKLE. Probably, and library. So these have kind of a unique sound to letter pattern. Our comprehension skill and strategy for this week focuses on main idea and key details. So the main idea is what your reading material is mostly about. What is the main thing they're talking about? So to find the main idea, you want to look at the title. You want to ask what the passage is about, so that reading material, what information or ideas are being repeated. Now, the key details give support or additional information about the main idea. So they give you more information about that main idea. They can include diagrams, explanations, facts, charts, descriptions, all of it related to the main idea. Your genre for this week is expository text. Now, expository text is informational text. So it shares information with the reader. It gives facts or it teaches about something. It has a lot of text features such as boldface words. That's when the words are written darker than the other words. It has headers or titles for different sections, so you know what each section is going to be about. They can have things like maps, pictures. They can have captions under the pictures explaining what those pictures are. These are all different things that you would find in expository text. Now let's jump into our vocab strategy. Your vocab strategy focuses on Greek roots. So a lot of the roots of common words that we use in the English language today come from the Greek language. Here are some examples. So the root geo means earth. So geology is the study of the earth. Geothermal is related to heat that's being released by the earth. Or geography is also studying the earth and the land around us. The root graph means to write. So an autograph is when someone is writing or signing their name. A digraph is when you're writing two letters where you're blending the sound. And a biography has the root bio in it also. That means about the self. So biograph means writing about yourself. A biography is the story about someone's life. So bio means life and graph means writing. The root phone, PHON, means sound. So a telephone or a homophone or phonology all relate to sounds. We also have the root eco, which means the environment. So ecology, ecocentric, ecosystems, those are all things that are related to the environment. Now for the grammar section of our notes, we're going to talk about different sentences. So a simple sentence is a group of words that expresses a complete thought. A simple sentence includes a subject and a predicate. Sarah likes to read. Sarah does not like to write. You can combine simple sentences to add some variety to your writing. And one of the ways you can do that is by using coordinating conjunctions and commas. Now, our coordinating conjunctions are words that are joining words. And we're going to focus on the words and, or, and but. So when you use coordinating conjunctions, you put a comma. You'll have your first simple sentence. You'll have a comma. You'll have your coordinating conjunction, so one of those words, and then you would have the rest of the thought or the second sentence. Now, when we do that, we create what we call a compound sentence. A compound sentence contains two related sentences that are joined by a coordinating conjunction, the words and, or but. These have different functions. So and is telling you that you're putting things together. But shows that you're changing or something happened to change the direction of what the plan was in that sentence or what was about to happen. And the word or shows that you're offering a choice. So you're picking one thing or another thing. Now, again, you always place a comma right before the coordinating conjunction. So I can say we went to the park, comma, and we went to the store. So those are two separate thoughts that I was able to combine using the word and a comma before that coordinating conjunction. We were going to the beach, comma, but it started raining. Or do you want to ride bikes, comma, or do you want to go for a walk? Now, one of the reasons we use coordinating conjunctions is to avoid what we call run-on sentences. Now, a run-on sentence is when you're joining two or more sentences incorrectly. You're doing it the wrong way. You're putting too many thoughts together that should be separated. So one way that you can correct a run-on sentence is to separate it out into separate sentences. So instead of saying, my sister and I went to the beach, we were so excited to see the blue skies and big waves, I'm going to separate those two thoughts. My sister and I went to the beach, period. That's my first sentence. We were so excited to see the blue skies and big waves. That's my second sentence. Now, coordinating conjunctions follow a rule. So you'll have your first sentence, you'll have a comma, the coordinating conjunction, and then you'll have the second sentence. Now, although we focused on the coordinating conjunctions and, or but, you actually have many of them. So one way to remember them is by remembering the word fanboys. Fanboys stands for and, nor, but, or, yet, and so. Those are your coordinating conjunctions, and they are used to join sentences. Now, each one of them has a different meaning. So the word for means because. Sam drank some water, for he was thirsty. Now notice there's a comma before the word for. You don't need a comma before the word and if you're just combining two simple sentences. I take milk and sugar in my tea. Nor, you're going to use a comma before that. That means and not. Sarah doesn't like apples, comma, nor does she like pears. But means however. All the children wanted to eat pizza, comma, but no one wanted to buy it. We have the word or, which means either. You're picking, you have a choice. We could go to a zoo, comma, or we could go to a theme park. We have the word yet. Yet means but. The weather was cold and wet, comma, yet we enjoyed it very much. And our last one is the word so. So means therefore. So he is sick, comma, so he is not going to school. It shows reasoning. Let's go ahead and get into your weekly stories. Your weekly story this week is an expository text like we were talking about, and it's titled Journey into the Deep.
Genre: expository text. Essential question: how do life forms vary in different environments? Read how animals in the world's oceans vary all the way down to the deepest, darkest depths. Journey into the Deep by Rebecca L. Johnson. Like a spaceship from a distant galaxy, the massive jellyfish hovers in the frigid water. Its meaty, dome-shaped bell is as wide as a doorway and the color of a bad bruise. Beneath the bell, fleshy arms twist and sway. The bell contracts, and the jellyfish glides backward. It relaxes, then contracts again. Contract, glide, relax. Contract, glide, relax. With a steady rhythm, the jellyfish pulses through the utter darkness of the deep sea. Until a few years ago, no one even knew that this species or kind of jellyfish existed. The scientists from California's Monterey Bay Aquarium Research Institute who discovered it nicknamed it Big Red. Big red jellyfish have probably been living in the deep ocean for hundreds of thousands of years. So why hadn't anyone seen one before? The answer is that even in the 21st century, the ocean remains largely unexplored. What we call the Atlantic, Pacific, Indian, Southern, and Arctic Oceans are all connected. Together, they form one enormous world ocean that covers about 70% of Earth's surface. On average, the ocean is 13,123 feet, or 2.5 miles, 4,000 meters, deep. We know less about this huge watery kingdom than we do about many planets in our solar system. In 2000, scientists from around the world set out on a 10-year quest to learn more about the ocean and everything that lives in it. They called their quest the Census of Marine Life. Several thousand researchers from dozens of countries began the largest ocean exploration in history. The scientists weren't just looking for new species, they wanted to get a better picture of ocean biodiversity. To do that, they needed to learn more about familiar species as well as any new ones they might find. They also needed to find out which species are common and which ones are rare. Finally, the scientists hoped to discover more about how different species are distributed in the ocean, from the surface to the sea floor and from pole to pole. How did census scientists explore something as immense as the ocean? They worked in teams. During the census, scientists got a closer look at many unusual creatures, like the barrel eye. This unique fish has a transparent head and huge eyes that can roll in many directions. Studied different parts of the ocean environment. Some teams focused on life in the shallow regions. Many others headed into deeper water. Studying the ocean can be almost as challenging as exploring outer space. You need ships and lots of special equipment. The hours are long and the work is hard, but you get a chance to be a true explorer, and you never know what you might find. In these pages, you'll have the chance to explore the ocean alongside teams of scientists working around the globe. You'll visit parts of the ocean few people have ever seen. You'll travel from the ocean's sunlit surface to its deepest, darkest depths. Best of all, you'll get a first-hand look at amazing creatures census scientists discovered in their quest. Scientific classification. Scientists classify or group living things based on their similarities. The smallest scientific category is the species. Living things that belong to the same species are very much alike. They can mate and produce offspring. Similar species are grouped together into a large category called a genus. Together, a living thing's genus name and species name make up its scientific name. Similar genera, more than one genus, make up a family. Families are grouped to form a class. Several classes make up a phylum, and several phyla together make up a very large, broad category called a kingdom. The animal kingdom, for example, includes all the different kinds of animals on Earth. Coastline. Depth below the ocean surface in meters. 2,000, 4,000, 6,000, 8,000, 10,000. Continental shelf. Continental slope. Dark zone. Trench. Abyssal plain. Mid-ocean range. Magma. Ocean surface. Deep sea coral. Seamount. Abyssal plain. Whale fall. Cold seeps. Deep sea coral. Coral reef. Depth below the ocean surface in miles. 1.24, 2.49, 3.73, 4.97, 6.21. Deep slopes. Propped up on one elbow, you're lying on your side. Your neck is twisted. Your forehead is pressed hard against the glass. Your muscles are cramping and you're getting cold. But none of that matters. As amazing as it is to explore the ocean with an ROV, remotely operated underwater vehicle, this is better. This is the real thing. Scrunched inside a submersible that has just passed 1,476 feet, 450 meters, you're descending through a dark world few people have seen. You stare out the small porthole, hardly daring to blink. Zooplankton drift and dart past the glass every few seconds. Many are bioluminescent. Somewhere below is your destination. You're with a team of census scientists who are studying a site on the continental slope of North America that stretches south into the Gulf of Mexico. Continental slopes are the submerged edges of continents. Some slant sharply down, forming steep cliffs. Others angle more gradually to the sea bottom. Your headset crackles. From the forward compartment, the pilot announces that there's coral dead ahead. Where? You can't see anything but black water. Then the submersible turns so your porthole faces the slope. A deep-sea coral reef as it looks from a submersible's front compartment. The sub's bright lights illuminate the scene. Outside is a pink coral as big as a tree. It's covered with electric blue worms. The sub moves slowly along the slope, past a garden of deep-sea corals. They have formed a huge reef here, like their shallow water cousins do near the ocean surface. Yellow, pink, orange, red, the colors of the corals are amazing. Of course, if the pilot turned off the sub's lights, you wouldn't see anything at all. These corals grow in total darkness, in water that's just a few degrees above freezing. How fast do deep-sea corals grow? The scientist sitting up with the pilot tells you that more species grow only 0.04 inches, 1 millimeter, a year. Your fingernails grow that much in less than 2 weeks. Scientists have analyzed samples of deep-sea corals to estimate their age. Some are hundreds, even thousands of years old. That makes these beautiful animals among the oldest living things on Earth. The sub moves slowly toward a clump of what the scientist says is bamboo coral. It has slender branches that divide again and again. As the sub gets closer, the pilot turns out most of its lights. The sub has a mechanical arm that can collect things underwater. The pilot uses it to reach out and touch the coral. A soft blue glow flickers up and down its delicate branches. This bamboo coral is bioluminescent. Next, you cruise over a massive patch of branching coral that's nearly as white as snow. The scientific name of this coral is Lophelia pertusa. It may be the most common reef-building deep ocean coral in the world, or at least on the deep reefs that scientists have explored so far. In this close-up of Lophila pertussi, you can see the tiny fleshy tentacles of the coral animals sticking out from the branches. They use these tentacles to snag bits of food from the water. Deep-sea coral reefs are home to many other kinds of living things. Almost every coral you see has at least one animal perching on it. Brittle stars and basket stars wind their long arms around and around coral branches. Long-legged squat lobsters and orange-headed shrimp hold on with pointed claws. The sub's cameras flash, recording different scenes. The pilot uses the mechanical arm to collect small samples of several different corals and put them into containers mounted on the front of the sub. Then you're leaving, heading farther down the slope. The coral garden fades to black as the darkness engulfs it. Chemosynthesis. Plants, algae, and some microorganisms use energy from sunlight to turn water and the gas carbon dioxide into sugars that they use for food. This process is called photosynthesis. Living things that carry out photosynthesis form the first link in most of the food chains on Earth. Much of what you eat, for example, either comes from plants or something that eats plants. In the deep ocean, where sunlight cannot reach, some food chains start with living things that carry out chemosynthesis. These organisms, mostly bacteria, use chemicals such as methane as an energy source for making their own food. Some animals living around cold seeps survive by keeping chemosynthetic bacteria in their bodies and sharing the food the bacteria make. Others live by eating the bacteria directly. A tiny species of squat lobster, new to science, sports rainbow colors. Census scientists found it on an Australian coral reef. Farther down the continental slope, bubbles start fizzing past the porthole. For one terrifying moment, you're sure the submersible is leaking air. The scientist calmly explains that you've arrived at a cold seep, a place where gases are bubbling up from the seabed. The gases are methane and hydrogen sulfide. If you could smell the water outside the submersible, it would stink like rotten eggs. Microscopic bacteria use these stinky gases as a source of energy in a food-making process called chemosynthesis. Billions of chemosynthetic bacteria live around cold seeps. What look like patches of white stuff on the sea floor are actually dense clusters of these bacteria. From the porthole, you spot what looks like a bush growing up from the sea floor. But as the sub gets closer, it's obvious that this is no shrub. It's a cluster of spindly, red-topped tube worms. The worms have no mouth or stomach. Tucked inside their long bodies are special organs packed with bacteria. The worms take in chemicals from the water and the sea floor that the bacteria need for chemosynthesis. The bacteria use them to make food for themselves and their worm hosts. Fist-sized mussels huddle in groups near the tube worms. Chemosynthetic bacteria live inside their bodies too. Tube worms, Lamellibrachia lumaceae, at a cold seep extend their feathery tops into the dark water. The rest of a tube worm's body is protected by a tough, flexible tube that's made of a substance similar to your fingernails. Tube worms like these may live to be as much as 200 years old. Several minutes later, and deeper still, the submersible glides over what looks like a small dark lake. Thousands of mussels surround it, crowding right up to the edge. These are similar to the bacteria-hosting mussels you saw at the cold seep. The fact that the mussels are here is a sign that the area around the lake is rich in methane. The pilot says the lake itself is a brine pool. The dark water is 4 or 5 times saltier than ocean water. Being so salty, it's much denser and heavier than seawater. The salty water has settled into a low spot here on the seabed. The water in the brine pool is too salty for the mussels. That's why they live around but not in it. At depths below about 1,970 feet, 600 meters, the water pressure is so great that methane gas freezes as it comes out of the seabed, forming methane ice. Here, the orange ice is covered with dozens of little hollowed-out spots. Nestled in each one is a slithery pink worm. The worms have a row of bristles on each side of their bodies. The bristles are moving, but the ice worms are not. They look as if they're all running in place. Methane ice worms, Hesiochaika methanicola, each about 1 to 2 inches, 2.5 to 5 centimeters long, sit in the depressions they've carved out for themselves in a solid chunk of orange methane ice. Countless mussels live around the edge of a brine pool. Ridges and vents. First, the ship sailed east. Then it sailed west. Now it's heading east again. You ask one of the scientists on this expedition to the southeastern Pacific Ocean what's going on. He explains that the ship is towing an instrument back and forth above the ocean floor. It's searching for signs of hydrothermal vents. A hydrothermal vent is a place in the ocean floor where hot, chemical-rich water comes blasting out. The towed instrument is searching for traces of this vent water. Judging by the excited shouts that suddenly fill the air, it's just found some. Several hours later, crew members ready the submersible for a dive. Your destination is a spot 7,500 feet, 2,286 meters below, on a part of the mid-ocean ridge called the East Pacific Rise. As the sub descends, a scientist explains that most hydrothermal vents are found along mid-ocean ridges. These are chains of undersea mountains on the ocean floor. They all connect to form the longest mountain range on Earth. Like stitching on a baseball, the mid-ocean ridge system winds for 40,400 feet, 65,000 kilometers around the planet. Your first glimpse of the mid-ocean ridge is a surprise. There's no soft mud here. The submersible's lights pick out masses of barren volcanic rock. These rocks are new pieces of Earth's crust. They formed when magma, or melted rock, surged up through a crack in the ocean floor and cooled in the near-freezing water. Slowly, the submersible clears a jagged ridge. On the other side, jets of what looks like black smoke stream up from chimney-like vents among the rocks. Moving plates. Earth's crust is made up of about 24 gigantic rocky plates that fit together like pieces of a jigsaw puzzle. Mid-ocean ridges mark the places where these massive plates are slowly moving apart. Magma from beneath the crust comes up at these spreading plate boundaries. It cools to form a new crust. In some areas, this new crust is riddled with hydrothermal vents, underwater geysers of dark, chemical-laden seawater that's as hot as 750 degrees Fahrenheit, 400 degrees Celsius. Left, this never-before-seen jellyfish is a new species. Below, black, blistering hot fluid erupts from a hydrothermal vent along a mid-ocean ridge. My first dive to a vent site was in the French submersible Nautil on the mid-Atlantic ridge. Traveling down through the dark water, I stared and stared out the tiny portal, and then suddenly the black smokers were in front of us. Eva Ramirez Yodra, Institut de Ciencias del Mar, Spain. Chemosynthesis powers life around hydrothermal vents, just as it does at cold seeps. These giant tube worms, Riftia pachyptala, take up chemicals from the water through their fluffy, plumed tops. Chemosynthetic bacteria inside the worms turn the chemicals into food. Around the vents, giant tube worms, as tall as a person, grow in great clumps. The scientist wants to get a closer look at these strange animals. The pilot carefully guides the sub through a maze of black smokers. Passing directly over one would be a serious mistake. The dark fluid is hot enough to melt parts of the submersible. Outside, the water pressure is enormous. If the sub cracked, you'd be crushed in an instant. After a few minutes of careful maneuvering, the sub is flanked by tube worms on both sides. Their feathery plumes sway just outside the portholes. Like their cousins at cold seeps, the worms harbor billions of chemosynthetic bacteria inside their bodies. The tube worms share their space with other animals. Snail-like limpets the size of mini jelly beans are inching their way up the outsides of the tubes. Scuttling among them are pink worms covered with scales that overlap like shingles on a roof. The sub moves out of the forest of tube worms and over a field of large mussels. They lie in heaps on the bottom, crowding out everything else. Ghostly white squat lobsters scurry over and around them. Mounds of mussels cluster so thickly at some hydrothermal vents that they completely obscure the ocean bottom. The Yeti crab, Kiwa hirsuta, was a major discovery during the census of marine life made by scientists with the French Ocean Research Institute, Inframer. Scientists gave it that nickname because its white color and hairy legs reminded them of the mythical, abominable snowman, or Yeti. Like some deep-sea crabs, the Yeti crab is blind, but it is so different from other crab species that scientists created a new genus and a new family to classify it. The Yeti crab in this picture is about as long as your hand. How do larvae find new vents? That's the main question. They cannot actively swim in a particular direction, especially against a current. At this point, we simply do not know how they do it. Paul Tyler, National Oceanography Center, Southampton, United Kingdom. In science, what is perhaps most important is to know how to ask good questions. Once you know the questions, you can go about trying to answer them. Myriam Saboué, Institut Oceanographique, Paris, France. Something else that's white catches the pilot's eye. He eases the sub closer and lets out a triumphant cry. It's a Yeti crab, a strange, newly discovered species with remarkably hairy legs. Yeti crabs have only been found at a few vent sites. They may be rare, but scientists can't really say for sure. The reason is that no two vents are exactly alike, even in the same part of the ocean. They'll have many species in common, but they won't be identical. What's even more puzzling are the differences scientists have found between vents in different ocean basins. Pacific Ocean vents like this one are home to giant tube worms, mussels, and clams. Vents in the Atlantic and Indian Oceans swarm with blind shrimp. Mid-ocean ridges are nearly continuous all the way around the world. So why don't vents in every ocean basin have pretty much the same collection of animals? During the census of marine life, scientists studied vents all over the world trying to answer that question. They still don't know. Just as baffling is how new vent communities form. Tube worms and other animals that cannot move produce eggs that hatch into larvae. Larvae drift off in search of new vents where they can settle down and grow into adults. But how the larvae find the vents remains a mystery. Solving these deep-sea puzzles is an enormous challenge. Every dive to a hydrothermal vent, however, yields a few more clues. When the time comes for the sub to ascend, it's hard to leave the vents behind. But you know you've just become a member of a small group of very lucky people who have seen them firsthand.
All right, that takes us to the end of our reading for this week. If you have any questions, please let me know. Otherwise, have a wonderful day. Take care. Bye-bye.